Chapter 3 Fundamentals of Machine Learning. We will start by introducing the fundamental concepts and principles of machine learning. Machine learning, ML, is a subset of artificial intelligence that involves the use of algorithms and statistical models to perform tasks without explicit programming. Core principles include concepts such as training and testing data, overfitting and underfitting, bias variance trade-off, and the general process of model selection and evaluation. Supervised learning. In supervised learning, we have a set of labeled training data. Each instance in the training set contains the input features and the corresponding correct output, or label. The goal of supervised learning is to train a model that, given the input features, can accurately predict the output. This can be used for classification problems, where the output is a category, like spam or not spam, or regression problems, where the output is a continuous value, like house price. Unsupervised learning. Unsupervised learning involves training on data that has not been labeled. The machine learning algorithm tries to learn the underlying structure of the data, or to summarize it in some way. This can include clustering, grouping similar instances together, anomaly detection, finding unusual instances, and dimensionality reduction, simplifying the data without losing too much information. Reinforcement learning. In reinforcement learning, an agent learns how to behave in an environment by performing actions and getting rewards or penalties in return. The goal is to develop a policy, which is a strategy that defines what action the agent should take under certain circumstances. Reinforcement learning is particularly useful for problems where there is a sequence of decisions to be made, like a game of chess. Reinforcement learning algorithms. Markov decision processes, MDPs, are a mathematical framework for modeling decision-making problems in an uncertain environment. An MDP is defined by a set of states, a set of actions, a transition function, a reward function, and a discount factor. The state of an MDP represents the current situation of the agent. The actions available to the agent are the things that the agent can do to change its state. The transition function describes how the state of the MDP changes when the agent takes an action. The reward function describes how much reward the agent receives when it enters a particular state. The discount factor determines how much weight is given to future rewards. Q-learning is a reinforcement learning algorithm that learns to map states to actions that maximize expected reward. Q-learning works by iteratively updating a table that stores the expected reward for taking each action in each state. The table is updated using the Bellman equation, which is a recursive equation that describes the relationship between the expected reward for taking an action in a state and the expected reward for taking an action in a subsequent state. Policy gradients is a reinforcement learning algorithm that learns to map states to probabilities of taking actions. Policy gradients work by iteratively updating a policy function that maps states to probabilities of taking actions. The policy function is updated using the policy gradient theorem, which is a theorem that describes how the expected reward for a policy can be improved by changing the policy function. Different machine learning algorithms. This refers to exploring a variety of algorithms used in machine learning, beyond the broad categories of supervised, unsupervised, and reinforcement learning. This could include specific algorithms like decision trees, neural networks, support vector machines, etc. Each algorithm has its strengths and weaknesses and is suitable for different types of tasks. Application of machine learning to real-world problems. Machine learning can be used to solve a wide range of real-world problems. This could include anything from predicting stock prices, recommending products to customers, detecting fraudulent transactions, to driving autonomous vehicles. The key is to identify a problem where machine learning can be effectively applied, to prepare the data correctly, to choose the right algorithm, and to tune it for optimal performance. Chapter 3, Fundamentals of Machine Learning Exercise. 1. Explain the difference between supervised and unsupervised learning. 2. Discuss the importance of data in machine learning. 3. Visit the website for a machine learning library like scikit-learn and browse the content. Chapter 4. Fundamentals of Natural Language Processing. Natural language processing, NLP, is a subfield of artificial intelligence that focuses on the interaction between computers and humans through natural language. The ultimate objective of NLP is to read, decipher, understand, and make sense of human language in a valuable way. Key concepts include tokenization, breaking text into words, phrases, or other meaningful elements, part-of-speech tagging, syntax tree parsing, and semantic analysis, understanding meaning from the text. Text classification. Text classification is a type of supervised learning that assigns predefined categories, or labels, to text. It's used in several applications, such as email spam detection, document categorization, sentiment analysis, and more. It involves learning from a training set of labeled documents and then using the learn model to classify new documents. Algorithms used for text classification can include naive Bayes, support vector machines, SVM, and deep learning models like convolutional neural networks, CNN, or recurrent neural networks, RNN. Sentiment analysis. Sentiment analysis, also referred to as opinion mining, uses NLP, text analysis, and computational linguistics to identify and extract subjective information from source materials. It's about determining the attitude, sentiments, evaluations, appraisals, and emotions of a speaker/writer based on the computational treatment of subjectivity in a text. This can be particularly useful for social media monitoring, brand monitoring, and understanding customer feedback. Question answering. Question answering, QA, is a computer science discipline within the fields of information retrieval and natural language processing, NLP, which is concerned with building systems that automatically answer questions posed by humans in a natural language. This involves understanding the question, finding the relevant data, and delivering the answer in a human understandable form. QA systems can be rule-based, where a set of predetermined rules guide the system to generate an answer, or they can be machine learning based, where the system is trained on a large dataset of question-answer pairs. How to apply natural language processing to real-world problems. Applying NLP to real-world problems involves understanding the problem context, selecting the right NLP techniques, pre-processing the data properly, and effectively implementing the chosen models. Some common real-world applications of NLP include information extraction, extracting structured information from unstructured text data. For example, identifying the key entities mentioned in news articles. Text summarization, automatically generating a concise summary of a long text. This is useful for quickly understanding the content of a document without reading the whole thing. Machine translation, translating text from one language to another. This is the technology behind services like Google Translate. Chatbots and virtual assistants. These applications understand natural language instructions and respond in kind, enabling humans to interact with software in a natural, conversational way. Chapter 4, Fundamentals of Natural Language Processing Exercise. 1. Use ChatGPT to research and explain the role of tokenization in natural language processing, NLP. 2. Discuss the challenges of understanding context in NLP. Chapter 5. Fundamentals of Computer Vision. Computer vision is a field of artificial intelligence that trains computers to interpret and understand the visual world. In other words, with computer vision, machines can visually sense the world, and interpret its content just like humans do. This involves processes like acquiring, processing, analyzing, and understanding digital images, and extraction of high-dimensional data from the real world in order to produce numerical or symbolic information. The fundamental concepts in computer vision include image processing techniques, feature extraction, and 3D reconstruction. Object detection. Object detection is a computer vision technique for locating instances of objects in images or videos. It's a key technology behind applications like video surveillance, image retrieval systems, and autonomous vehicles, where it's crucial to understand the context of what's being seen in an image. Object detection models are usually trained using supervised learning algorithms. They combine the use of object localization, to locate the presence of an object in an image and indicate it with a bounding box, and object classification, to predict the type of object that was localized. Image classification. Image classification is the process of categorizing and labeling groups of pixels or vectors within an image based on specific rules. The task of image classification is to take an input image and predict the class of the image. This is a type of supervised learning where the model is trained with a dataset of input images and their respective classes. Once trained, the model can classify new input images into these classes. Convolutional neural networks, CNNs, are commonly used for image classification tasks due to their success in capturing spatial information in an image. Face recognition. Face recognition is a method of identifying or verifying the identity of an individual using their face. This involves several steps: face detection, finding faces in images, face alignment, aligning faces based on eye positions or other landmarks, feature extraction, extracting features from the aligned face that can be used to represent the face, and finally face matching or classification, comparing the features to a database of known faces. The feature extraction step is often done with a deep learning model, where a convolutional neural network, CNN, is trained to output a compact but rich representation of the face. Computer vision techniques are used across various domains like medical imaging, self-driving cars, image restoration, and more. Learning these topics will provide a good foundation for anyone looking to dive deeper into the field of computer vision. Chapter 5, Fundamentals of Computer Vision. 1. Explain how convolutional neural networks are used in computer vision. 2. Discuss the applications and limitations of computer vision. Chapter 6, Fundamentals of Prompt Engineering. In this chapter, we will explore the fascinating topic of prompt engineering and its significance in the field of artificial intelligence. Prompt engineering plays a crucial role in ensuring that AI models produce precise and robust outputs based on the given prompts. A case for prompt engineering. As AI continues to advance and integrate into various aspects of our lives, it becomes essential to understand how prompts shape the behavior and decision-making of AI models. The prompts we provide act as instructions that guide the AI in generating the desired outputs. Therefore, the quality and specificity of the prompts directly impact the accuracy and relevance of the AI's responses. Prompt engineering is particularly crucial in the realm of natural language processing, NLP, where AI models are designed to understand and generate human-like language. By carefully designing prompts, we can ensure that the AI accurately comprehends the task at hand and generates responses that meet our expectations. The importance of precise and robust prompts cannot be overstated. They serve as the foundation for effective communication with AI models, enabling us to extract the desired information or achieve specific tasks. When prompts are vague or poorly constructed, the AI may struggle to understand our intentions, resulting in inaccurate or irrelevant outputs. Good versus bad prompts. Consider a scenario where we want to translate a sentence to French. A poor prompt would be translate this sentence to French, as it lacks the necessary information. In contrast, a good prompt would be please translate the following sentence into French: I would like to order a coffee and a croissant. The latter prompt provides clear instructions and specific details, ensuring that the AI understands our request accurately. Another example can be seen in a writing task. Asking the AI to write a short story is vague and leaves room for interpretation. However, a more effective prompt would be write a 500-word short story that includes the following 3 elements: a red balloon, a deserted beach, and a mysterious stranger. By providing specific criteria, we guide the AI's creativity and ensure that the resulting story aligns with our intentions. Explicit prompts. Explicit prompts are commands or instructions that precisely articulate the task the model needs to perform. These prompts are characterized by clarity and specificity. They leave little to no room for ambiguity, as they detail the nature of the output the user expects. An explicit prompt can be as simple as write a poem about a flower. Here, the user is expressly asking the language model to compose a poem, and the subject of the poem is clearly defined as a flower. The instruction is direct and unambiguous. Explicit prompts can also be more complex, requiring the model to perform tasks involving a series of steps. For example, consider the explicit prompt: read the following text and summarize it in 3 sentences. The model is clearly instructed first to read or process a given text and then to produce a summary condensed into 3 sentences. The effectiveness of explicit prompts lies in their precision. They provide a roadmap that the model can follow, enabling it to generate responses that align closely with the user's intent. Explicit prompts also enhance the model's ability to handle tasks that require a structured response. In the context of a writing task, for instance, an explicit prompt like "write an essay discussing the causes and effects of climate change" will guide the model to produce an essay that not only addresses the specific topic, climate change, but also covers the specific aspects of the topic, causes and effects. Explicit prompts can be particularly useful in educational and professional applications. They can guide language models to generate specific and structured responses or content, such as essays, reports, lesson plans, business plans, code snippets, and more. Implicit prompts. Implicit prompts, on the other hand, convey the task to the language model in a less direct manner. These prompts are often more open-ended, leaving room for interpretation. The user is still guiding the model's response but in a less restrictive way, allowing the model to generate a broader range of responses. Take the implicit prompt "describe a flower," for example. This instruction doesn't specify the format or structure of the response. The model could choose to describe a flower scientifically, focusing on its biological characteristics. Alternatively, it could take a more poetic approach, describing the flower's beauty and fragrance. The prompt guides the model to provide information about a flower, but the nature and style of the response are left open-ended. Implicit prompts stimulate the model to exhibit its creative and generative capabilities. For instance, if a user provides the prompt, "It was a dark and stormy night," the model might generate a suspenseful short story, an atmospheric poem, or a descriptive paragraph. The ambiguity allows for a multitude of possible responses, each displaying the model's ability to create original content based on the given trigger. Implicit prompts also allow users to explore the model's ability to adapt to context and extrapolate from incomplete information. For example, if a user provides the prompt, "As the sun set," the model could continue the narrative in a variety of ways, depending on the context provided or inferred. Implicit prompts can prove useful in a range of scenarios, particularly those that benefit from creativity, variety, and exploration. They can help generate diverse narrative content, ideate for brainstorming sessions, or even assist in creating various forms of artistic expression, such as stories, poems, and scripts. Prompts in image generation. In the same vein, prompt engineering plays a crucial role in image generation tasks. When requesting an image from an AI, it is essential to provide clear and precise prompts regarding the desired style, subject matter, and other visual characteristics. For example, instead of simply asking the AI to generate an image of a cat, a better prompt would be "Please generate an image of a white Persian cat sitting on a windowsill, looking out at the moonlit city skyline." This level of detail ensures that the AI produces an image that matches our specific requirements. Good prompt structure. Prompt engineering involves designing prompts that are concise, focused, and accurately convey the intended meaning. It requires careful consideration of the context in which the prompts will be used and tailoring them accordingly. For instance, a prompt designed for a chatbot would differ from one designed for language translation. Active verbs can bring more energy and urgency to prompts, making them more effective in guiding the AI's decision-making. Additionally, incorporating relevant domain-specific knowledge into prompts helps align the AI's responses with the desired outcomes. It is also crucial to consider the audience for whom the prompts are intended, as this influences the language and tone used in the prompts. To ensure the effectiveness of prompts, it is essential to test them with real users and gather feedback on their clarity and effectiveness. Continuous iteration and improvement of prompt design based on user feedback and performance metrics lead to more effective AI models. The importance of good prompts. Prompt engineering is a critical aspect of developing AI models that can generate high-quality outputs meeting the needs and expectations of users. By mastering the art of prompt engineering, we can leverage the power of AI to automate tasks, enhance decision-making processes, and streamline various aspects of our lives. 3 rules for effective prompts. 1. Be clear and concise. The large language model, LLM, should be able to understand what you are asking for without having to guess. 2. Provide enough context. The more context you provide, the better the LLM will be able to generate a response. 3. Be specific. The more specific you are, the more likely the LLM is to generate a response that is relevant to your needs. Why the RGB model? In the following chapters, we will dive deeper into the intricacies of prompt engineering, exploring various techniques and examples to illustrate its practical application. We will examine the role-goal-benefit, RGB, prompt language model, which is derived from the concept of user stories and offers a structured approach to prompt design.